we just computed this delta time, which would happen between node on and node off, say, as 384. What's 4 times 96? So that was a whole node. Okay, and we'll see that through the examples, how the delta time works. This is one of those things where you either explain it before you see it, and you kind of wonder why it's being explained, or you wait till afterwards. Well, this time it's going to be before we see it. So we'll see. Here's an example. This is taken from a book that I gave some copies of. It's unfortunately, as far as I can tell, out of print, called the Music Technology Reference Book. It's a great book, covers MIDI very nicely, covers a ton of other things. It's in the references for this presentation. Very useful. I hope it does come back in print at some point. It was great. And it also covers all kinds of things. Recording and electronics, everything. Every chapter is a completely different subject, much like this course, every lecture is different. Okay, so the example file. So if we were looking at, imagine these bytes would obviously be sequential, but I've broken them up for clarity. So the first 4 bytes is the header. So this is just the ASCII values for NTHD. Second thing is the length, 6 bytes, which is standard for a header, because a header has pretty much a fixed format. The first 2 bytes are the file format, which is 1, multi-track synchronous. There are 2 tracks total, and it's 96 pulses per quarter minute. Okay, so here's the first track. So starts off with M track. The length is 26 bytes. Now the first one we look at, we see that it has 0, 0 for the time. So effectively everything happens right at the start. So the delta time is 0. And then you see FF. OK is one of these meta events. It's meta event 58. Well, what is meta event 58? That turns out to be the time signature. Oh, excuse me, 5804 tells you the meta event. These 2 things tell you the meta event. So what is the time signature? Well, you look at this one, and this tells you the numerator is 4. This one tells you the denominator. But it doesn't tell you the denominator directly. It tells you the denominator as log base 2. So if it's 4, 4, log base 2 of 4 is 2. If it's 6, 8, log base 2 of 8 is 3. Why they did that, I'm not sure. I guess because you always have your numerator, or your denominator is always a power of 2.
Yeah, they didn't want somebody to put some music in like 4 bits.
I guess. Yeah, I guess. Yeah, exactly. It didn't have some use. I don't know. Okay, so that's these 2. And then this tells you how many clicks per metronome beat. I'm not exactly sure. And then these, how many 30-second notes are in a quarter note. And the answer is 8, which seems obvious, but I think that would change for different time signatures. That's one of these things that I'm not, it seems obvious at the time, so I'm not completely sure what the usefulness of the last 2 are. But if I were more experienced with it, okay, so that's that meta event. The next meta event, FF5103, is the number of microseconds per quarter minute. So what this is it takes these 3 bytes, right? It only takes the 7 least significant bits, of course. So you take 7 bits from here, 7 bits from here. Oh, actually, no, maybe this takes, I'm sorry, this takes everything. You combine them together, and you find that if you convert hex value 78120 to decimal, you'll get 500,000. So what this tells you is how many microseconds per quarter note. So 500,000 microseconds per quarter note, if we invert that, we figure out, well, that's 120 beats per minute, right? Because you get 2 quarter notes per second, 60 seconds in a minute. Okay, now let's look for the next thing. Well, the next thing says, this should be patch. So this is change to patch 5. Okay, so it's got patch change commands built in. Well, that's useful. What is patch 5? Well, that's one of the general MIDI standards. I forget what it is. But this is useful because remember I said you can embed ASCII text, you can embed the instrument name, but you can also embed the patch change. So you can say piano and put it on the patch for piano. You can say voice and put it on one of those cheesy voice patches that makes apu with on noise. And then the next thing is a node on command, right? So at time 0, we get 91, node on, channel 1. 3C is C3, the 1 octave below middle C, and a velocity of 100. So moderately loud. Then 60 clock ticks later, we get a note off command, which again is really note on with velocity 0. Now, we know that there are, what did I say? There were 96 pulses per quarter note, or 60 and a half. So this is 1 quarter note. And then every track ends with the same command, 00FF2. That's in the track. Here's another file. So this is again simultaneous track. It's shorter in length. Actually, it should be 26. It should say 14. So although they're played simultaneously, they may not be the same length, right? Because you're encoding MIDI events. So if one track just has a note on at the beginning that holds a note forever, and a note off and then it ends, and just one incredibly long delta time, it could take up the same amount of time as some other track that has a whole bunch of note changes. But so they won't be the same length.
So the this first one, this first I guess point there, you could so the order does not matter. You can put in like 83, you put like 60, you would play quarter note beforehand, right? Or would it put in order? Like how like if you played one note and you played another after, but you say you like a lesser value, would it rearrange them into the time order as it's supposed to?
Wait, hang on a minute. Oh, if you were to like specify it in a file.
Like if you said 60 and then the next one you said like, 3 hex 30.
Yeah.
Would it put it back in the right order?
No, because these aren't time stamps, they're differential.
Oh.
So what this, that's a good question. What this is saying is that this occurs 60 after that. So if you had another one that had 30, like you're saying, it would say it's 30 after this, it's 90 after that.
All right, that makes sense.
So yeah, so that way they don't have to encode any kind of time stream, it's just differential from the last event. Okay, so this one, again, differential, so you can do things simultaneously by having differential 0. So it changes the patch time, turns on the note at time 0, and then we look at the time here, and it's 8300, where if you were to calculate that, like we did before, that turns out to be 384, which is 4 times 96. So it's effectively a whole note. And then end of track. Okay, so here we go. Let's look at an example. We'll give you example A, draw on it as we go through. Okay, so what's the first thing you see? Yep, so that's the first 4 bytes. Okay, after that, what's next?
There's an F after. Oh wait,
Yeah.
next
4 bytes after the first 4.
Oh, the next 4 is just all the zeros. 6 is oh, it's the
Yep. So there's 6 bytes left. All right, and actually we can go back up and work with the paper. So all right, so 6 bytes. So what's after that? So you got 4 bytes that tells you the length is 6. Then after that you've got 0001. So that tells you the 5 format. Right.
And then after that, 4 tracks.
4 tracks. Yep.
And the next, only 2 more bytes.
Yep.
Let's do that's 16.
Well,
Not 16, not fancy.
it's 15 times 60. It's 240.
Uh,
So that tells you that's the pulses per quarter note.
uh,
So again, that's the clock ticks per quarter note. So when the program reads this, it sees it says okay, 240